are not always ideal, so if you can't hear me, just let me know. So I'm talking about algorithmic art using Turtlestitch. If anybody's met me before, you know I'm really passionate about using Turtlestitch. I teach at the University of Warwick, and I also coordinate the outreach team for my department, which is Warwick Manufacturing Group, WMG. So we're a traditional engineering department, but now we do a lot of different things. And so I use Turtlestitch to help young people understand how maths, computing, design and technology all work together in engineering. So it gives them an insight, because engineering is not a subject that is really taught in schools. So if we want people to go into engineering as a career, they need to know a bit more about what it involves. So this is some of the designs I'm going to go into in a minute. But I titled this talk, Algorithmic Art, rather than generative art. It's algorithmic deliberately. And it's art that's created with rules, logic, and computation, and sometimes randomness as well. So it can take lots of different forms. This is not something that's new. This is something that's been around for a very long time. There are some lovely examples. The other thing that fascinates me, I think, is because of the Turtlestitch I'm used to doing, which is programmatic embroidery, there's a lot of links to line plotter art. And there's a lot of work being done in this area in the 60s and 70s. So I thought I'd start off by sharing some of the people that have done some beautiful things in it. Vera Molnar is an example. She created this structure of squares, and it's got a bit of randomness involved in there. But 1974, so it's quite unusual to find people using computers in art, and you can see the lovely old line printer paper. This is Frederick Nake, homage to Paul Klee, and this dates from 1965, so it's even earlier than the other work. But again, it's done in line plotters. There's elements of randomness in there. I've put the links in there so that if you're interested in any of this, the V&A in London has got a great collection of this that you can book and go and see. So it's really lovely to see these things. The last one I'm going to show you is one done by Clive Richards. Clive Richards worked at the time at what became Coventry University. It was the Lanchester Poly at the time. And a lot of the work, exciting work in computer art, was actually done in polytechnics in the UK. Universities were doing work looking at developing computer languages and more theoretical things. So the polytechnics were really exploring the application side. So this is Clive Richards, 100 Cubes, 1973. And I was drawn to this because he was based in Coventry. He did lots of different things. This is again in the V&A. But Coventry was City of Culture in 2021. Unfortunately, we had COVID as well, so that kind of impacted on things. But as a sort of celebration of Coventry City of Culture, I realised a line plotter is very much like an embroidery machine. It's just on textiles. So I started implementing Clive's work. And so you can see the two sides of it. And this exactly follows his form. And if I go back to his original, he'd hand-coloured his in, which is where he got the colour. I did it in two tones, so I did it in black and white because Coventry was the city where two-tone emerged from, so it was kind of like a homage to it. And Clive was very generous. He loaned me one of his original plotter drawings, so we were able to exhibit all this work together, which was really nice. Okay, so I spoke a bit about Turtlestitch. Turtlestitch, you can see an example up there. It's turtle graphics, moves and turns. But what is really nice is you're able to produce tangible things from it. And it links to culture, because if you look at our clothing and things, we've all got patterns and things on our textiles, whether on us or in our homes or wherever. So there's a lot of links, and especially in a city like Coventry, where there was hundreds of years of migration, there's a lot of rich cultures there. So there was a lot of work we did with schools in this area. So you can see examples here, and it was developed, it's open source, it's developed by Andrea and Michael. And we're quite a nice community, we're all over the world now. And we meet once a month to share what each of us has been using Turtlestitch for. So this is an example of it, and it's a little animation. I didn't write this code, it was written by a child, but what fascinates me is you can't tell. When you see the final thing, it looks like a sort of, I don't know, crystal structure. It doesn't look like it's made up of sort of blunt triangles, which I really, really like that. And if I look at the examples of it being stitched, this is speeded up. The examples of it being stitched, it follows the same pattern. So when you give a child a copy of their work, it kind of, they remember how they created it. So there's a sort of really valuable link. And I work with children as young as 9. I'm not a trained primary school teacher, but I work with the teachers for children as young as 9, so that they can get that physical, tangible things created. Oops, I'm going to go back. The whole workflow, if you like, is you write code, you save it in the machine format, and I've become an expert, unwilling expert in embroidery machine languages. You transfer it to machine, usually by USB memory stick, it's the most reliable, and then you stitch the designs. So this is just, I thought I'd put this in just to show you the kind of things that we do with the children, finger puppets, key rings, whatever. So schools are really enjoying using it, and I've got a network of 9 primary schools where I've managed to get funding from various sources, because a lot of the schools in our area are not really well off. They need help. So this is something that we've been able to help them with. Okay, so I think I annoy people a bit because I often refer to this as a different kind of physical computing. It doesn't involve sensors, if you like. It doesn't involve Internet of Things and sensing stuff. But it's tangible, it's physical. And young people in their classrooms, a lot of the schools teach them games. So they make games, and that engages with some of them, but it never seems to engage with everyone. Whereas this is very creative. It does get very strong engagement. If I don't get a woo out of a primary school class about halfway through a workshop, I think something's gone wrong. So you can stitch different things, mathematical functions, fractals, repetitive patterns, tiling, data visualization, sounds, noise, randomness. We can stitch all of them. This weekend, I've taken my embroidery machine with me. So if any of you do wish to sort of explore Turtlestitch, do come along and let me know, and we can look at your pattern and stitch it if there's time. I do have some manufacturing constraints. I've only got a 10 by 10 centimeter hoop, so it's got to fit in there. But come and speak to me if you want to do some turtle stitching. It's a bit addictive. So this is the kind of patterns we'll see from young children 9 to 11. We tend not to work with younger ones because 9 is where they really feel confident, start feeling confident about angles. Now most of this is rotation. So we teach them how to do a shape, And the woo comes when you show them to rotate it. And then you explain how they calculate how many times to rotate it. So there's some good mathematics in this. And it gives the teachers, let's say to us, it gives the children a bit of resilience, and it also gives them a reason to apply and work out their angles. So anyway, this is what you get when you run a workshop at a maths conference. I ran a workshop on recursion to a bunch of mathematicians, and you get this joyous patterns. And it works as well from 8 to 80. In fact, we've had several retired teachers that were over 80 that came and had a go as well. So there's a lot of fun to be had in doing these things. I'm going to come back to some of the stuff I did during lockdown that I called emerging patterns. I was at home with an embroidery machine, so I just started doodling. Now, what I'm doing is not art, I know that, but it's closer to doodling with things. And so these are just some of the examples of what I came up with, using very, very simple algorithms. I don't suggest the patterns are, not the patterns, I don't suggest the code is particularly good, but it just was my brain freestyling along, trying things out. So I thought I would just talk through some of the tactics I took. A lot of my patterns just start with a line, and literally the function is just move forward, turn, come back, turn. And it was just variants of that. And it just started to fascinate me. Maybe lockdown we all just went a bit funny, I don't know, but certainly I just got fascinated by this. So this is just a variant where I'm just turning round. So I'm calling a line out and back, hopping a certain number of degrees, and so on and so forth, and just repeating it, and start to get bigger patterns. And what I loved about this is how you got unexpected patterns coming out. Because the stitches are 2mm stitches, you started to get these ripples and ridges and things. So it just fascinated me, this sort of, your eye makes up the square, if you like. There isn't a square there, but it makes it there. It makes it look like butterflies. So I just explored them. Don't tell me the code's not great if you look at it. It was just me having fun. Then we tried squashing things, and overlapping stuff. And again, you can see all of this beautiful ripples coming through, purely as an artifact of how we're creating it using an embroidery machine. If I'd done a plotter, you wouldn't have seen that. So there's something here about how we manufacture things, which I find quite fascinating. And more stepping out, coming back again, but now doing it in a circle and repeating it in different ways. The one on the far right at the bottom was just throwing in a bit of randomness in there as well. All of these things, although I'm stitching them, you can actually export them as SVG files and put them onto a laser cutter or whatever as well. I got fed up of lines at this point, so then I discovered tatami stitch. Tatami is a space-filling stitch. And so as the turtle moves that way, he's building a wide path rather than a narrow stitched path, if that makes sense. And I discovered that you could knock the turtle to the left, and so the pattern the turtle created was off to the right-hand side. So you could create blocks very easily. So then I started creating grids and blocks and things. So you could do checkerboards and all sorts of other things. And I'm just swapping between two different stitches, and that's simply all that's given me this nice effect. So you started doing optical illusions at this point. I hope I can't hold my camera on my phone straight, which is why there's all of these slightly odd parallax angles coming out. But anyway, so I had a lot of fun with the tatami stitch. And then I started doing odd tiling patterns. So this is just the block, repeated in different ways. Okay. Got fed up with tatami at this point and started exploring other ways of doing things. So now I'm looking at doing how we do diamonds, controlling the height of the spikes. So the turtle is moving up, down, and then hopping across. Up, down, hopping across. And I'm controlling the height of the turtle. After I got fed up of that, we then moved on to the next one, which is changing the height of the turtle, but also changing the step. So I've got two variables in there. So we get a denser pattern and a wider spread out pattern. And I had a lot of fun with this as well. Then doing sort of visual illusions with this. I ended up doing these animations because people kept asking me, how do you do these things? And if you see them being stitched in the animation, you immediately get it. Anyway, so that's just the kind of patterns that occupied me for a while. I'm going to just move on. This is some examples of the children's work that was created. The wall there doesn't look very high, but it's actually 3 meters, and we had the work of 480 children on that wall. So it's very exhibitable. It's very, libraries like it. Art galleries and museums. So this was in the Coventry Transport Museum. We had the display of the children's work. We've developed a lot of resources. So if you do want to try Turtlestitch, go to warwick.ac.uk/Turtlestitch and you will get all of my resources. There's a lot there. There's little zines, there's videos, lesson plans for schools. There's a lot of things. Before I finish, though, I wanted to just share 1 or 2 other things that in the Turtlestitch community, we sort of get excited about different patterns. And in 2019, Joek van Montfort from the Netherlands started showing us some very unusual patterns. And this is Spakowski. Apologies if I'm not pronouncing the name correctly. And these are ink on tracing paper, and they're a single line drawing. And they're just very, very beautiful. I mean, Joek had a chance. Joek went and stitched some of these, and Elaine Wolfe in the Turtlestitch community also kind of got the bug and translated these into Turtlestitch. I haven't felt the need. I think I've gone through my lines phase, and I don't know what I'm doing now. But if you look at it, it's very beautiful and very carefully thought out. And he was creating this in 1930. He kept his work together. He created this work from the age of 17. And in his 80s, he published a book, Rhythmical Lines. So they were obviously very precious to him, but nobody knew about his work until after he'd passed away. So that's one of them. I thought I'd just share some more beautiful patterns to finish. This one is absolutely fascinating. It sort of starts here, goes round, goes up, goes back, comes back here, and then comes down, back, and then off, and back up again. So it's just so beautiful, these pieces of work, and I just thought people would like to see them. 1928, 1926. And one last pattern to start, and I think this is my favorite, this one. It just sort of starts here and off it goes. Anyway, if you search for him, you'll find his patterns, and it's worth having a look at them. And if you fancy trying to work out the algorithms, I can try and stitch them for you. It's a challenge to you. Okay, thank you very much for listening. Any questions? Yeah, so you can implement sign functions, you can do a lot of things. There is an arc command. You need to be careful because you don't want the stitches to become too small because you're punching a needle into fabric. So if you make tiny stitches, 10 units in Turtlestitch is 2 millimeters. So if you make the stitches too small, you end up almost cutting your fabric. But yeah, arc command, there's arc left, arc right, and you can just go to the next location. Yeah. You're doing your exercise today. Around this side.
Could you make like a, I know it kind of goes against the algorithmic abstract idea, but could you make like a non-abstract thing, I don't know, a smiley face, something like that, using the algorithmic patterns?
Could you make what was it? I didn't catch the word. You give an example.
Oh, like say a smiley face or a dog, or
you can
using
do that.
the algorithmic repeating.
Yeah, and people have written code so that the turtle follows the mouse, so that you can drag wherever the mouse goes, so you can have a sort of etch-a-sketch kind of thing. So there's lots of different, and if you go on the Turtlestitch website, you'll see people's examples. A lot of the time people are processing things mathematically, so they're making a denser stitch where it's darker and less dense stitch where it's lighter. So there's been a lot of algorithmic work in that nature to create things.
Are the machines, what's the cost of the machines? Are they readily available?
They're readily available, but they cost about £1,000. The advantage, I'm trying to tell schools, if they've got funding, to not buy 3D printers, because embroidery machines, one embroidery machine will do a whole school, and it will sit and stitch people's work in 2 to 5 minutes. Whereas with a 3D printer, if you do a workshop, and we used to do workshops with classes, we came back and we'd spend 2 weeks modifying and 3D printing stuff and letting it fail and whatever. So I'm now very committed to the embroidery machine. And there's enough plastic in our world. One 3D printer cannot do a class, let alone a school. So. Yep. Yeah, and I've been trying to link up schools sometimes with some of the hack spaces because it is an issue for schools. And they sound expensive, but when you've got one that does a whole school, it's quite reliable. And if you need it serviced, you just take it back and get it serviced. 3D printers are not often as easy to service.
It's a rather almost Luddite one. Rather than printing to an embroidery machine per se, could you print it to a paper pattern to be done by hand instead?
You can print them out. You can export them as an SVG and then print that and scale it. One of the problems with an embroidery machine is you're stitching something and there's a finite size to stitches. So actually exporting it as an SVG means you can scale it to whatever size you want. Embroidery machines will let you scale things by about 10%, and then that's about it. And there is examples, actually, some of the African groups that other people have worked with, they didn't have access to a machine, so they were actually hand-stitching their designs because that was the only access they had.
Just to add something that I'm sure you'd have mentioned when you asked about printing them out, another thing you can do is effectively use the embroidery machine as a punch on paper or card to make perforated designs you could use as lampshades and so on.
Yeah, Thank you, Robert. In fact, if you Robert's demonstrating one of the T-shirts. Yes, he's got a the dragon curve, I think, is the. But I don't have a big hoop to do that. I've only got a 10 by 10 hoop. Okay.
Any other questions?
It was
Well-
completely different to what you've had earlier, so yeah, you go.
Well, thank you very much. Margaret Lowe.
Thank you.